Lesson 8.5 is about direct variation. And here, for example, this is an amplifier generates intensity of sound from watts of power in a constant ratio. The sound output varies directly with the power input. So in other words, we input the power, and then however much power we put in, then the sound comes out of it. And if you're old like me, we don't like a lot of sound. We don't like a lot of input because we get too much output. But I used to be young once too, so I understand. So we have a direct variation is a linear function, so we're going to have a line here, linear function, that can be written as y equals kx. Y equals kx. K is a non-zero constant, so k is a number, it can't be zero, and it's called the constant of variation. So here they want us to take this equation, y equals kx, and they want us to solve it for k. So we have y equals k times x. If we solve this for the k, then we have to split apart the x, so we divide the x. So another name for k is the ratio of the y to the x. So the constant of variation is the y value divided by the x value. And it says the ratio is the same for all ordered pairs that are solutions of a direct variation. Since the rate of change k is constant for any direct variation, the graph is always linear. And this is important right here, I underlined it. The graph of any direct variation always contains the origin, 0, 0. Because for any value of k, 0 equals k times 0. That's true. No matter what k is, 0 equals k times 0 because k times 0 is 0. So let's go ahead and do a couple of these. This is the table shows an employee's pay per number of hours worked. Determine whether it shows direct variation. Well, to determine whether it shows direct variation, we have to make sure that the ratios are all the same. So I have to make sure that 9.5 divided by 1 is equal, because remember it's x or y over x, equals 19 divided by 2 equals 2850 divided by 3, etc. So I have to make sure that all of these work. So what I can do is I can make sure, for example, that these two ratios are equal by doing cross products. This is one of the easiest ways. So 9.5 times 2 is 19, and 1 times 19 is 19, so it works. I could do the same thing. Let me use a different color here. I could do the same thing with these two ratios in the proportion. So I need to make sure that their cross products are equal. So I have 19 times 3 is 57. And I have to see, does that equal 2 times 28.5? And it does. So yes, this is direct variation. Here it says find the equation of a direct variation given that y varies directly with x. Well, remember, we have to find k first. So k is y over x. So my k in the first one is 12 over 3, which equals 4. So my equation is y equals 4x. I don't have to put plus 0 because I know that 0, 0 is in the equation. So let's go ahead and look at this next one. Again, I need the k value. So y is 18, x is 6, so k equals 3. So my equation is y equals 3 times x. And that's all there is to this. So k is 360 divided by 3. So k is 120. So y equals 120x. And then my last one here, k equals 4 over 36, which is 1/9. So it's okay to have a fraction. So y equals 1/9 times x. So there's the direct variation, how you write the equations. Alright, next it says the table shows how many hours it takes to travel 600 miles depending on your speed in miles per hour. Determine whether there is direct variation between the two data sets. If so, find the equation of direct variation. So I'm going to see if these are proportional. So 120 over 5 should equal 100 over 6, and then I'll just do the last one, should equal 10 over 60. So we'll look at that. So when I do my cross product here, I get 500 equals And then we'll try it. 120 times 6 is 720. So the answer is no, not direct variation. And we don't have to find the equation because it's not direct variation, so we are done. All right. If you'd like to start your assignment, I don't have it written down yet, so I guess I'll just have to get it to you at another time. Sorry.